Hi everyone, welcome to the lesson on current. If you have your textbook, turn to page 71 to 75, where we'll talk about current. And later on, when I talk about current in series and parallel circuit, you can then turn to page 80 to 83. So it's good to have your textbook next to you. You can pause the video at any time to do reading if you wish, right? So before we start, you need to be familiarized with the electrical circuit symbols. So these are the symbols that you need to know what they represent. So of course, the more common ones will be your lamp, and will be your lamp. This is resistor, fixed resistor. That means you can't change. If you have a 2 ohm, it's 2 ohm all the way. This is a variable resistor. That means you can adjust and you can change the resistance. Do not get mixed up. These two are very similar to another symbol here, which is the fuse. Okay, as you can see, the fuse has a line drawn in between. The voltmeter, ammeter would be the appliance that the equipment that we use to measure voltage and current. And this is a symbol to represent alternating current supply. The current that's flowing in our house is alternating current. All right. If I want to show the energy supply, let's say from your socket, this is the symbol that I will use. This is when you for earth, that is in the chapter of practical electricity. We'll talk about that later. Electrical cell means when you have only one. Okay, so if you buy a AA battery, so this is an electrical cell, just one. But if you connect them in series, 2 of them or 3 of them or 4 of them, then we call it a battery. Of course, knowing them, the circuits, you'll be able to draw a diagram. So what is actually electrical current? Electrical current means tiny electrical charges that's flowing in the circuit. Now, in every circuit, we have connecting wires, right? We have conductors, and there are charges that's actually present in all these wires. But normally, they will not flow on its own, or else we'll get electric shock every time we touch a wire, right? But once you connect electrical cell or a battery to it, this one provides a push. Okay, so it will push. And what does it push? It will push the charges to start flowing around. So when the tiny charges starts to flow around, we say that a current is flowing. If the current flows very fast, we say that it is a big current. If the electrical charges flow slower, we say that it's a small current. Do note the definition for current, the rate of flow of charges. That means how fast it flows. And when we draw current direction, we always draw them from the positive to the negative terminal. This is the symbol. When I want to represent current and I don't want to write out the word, to spell out the word, the symbol is I. So in the formula, every time you see I, it means current. And of course, when I measure current, let's say it's 2 or 4 or 5, that's in ampere, right? The SI unit is in ampere. Current can be very small, so milliampere is used as a unit very often. So what happens is if you have current and you want to change it to milliampere, you multiply by 1000. And if you have milliampere and you want to convert it to ampere so that you can use in the formula, then you have to divide by 1000. You can use an ammeter to measure current. Do take note of 2 things when you use ammeter. Number 1, ammeter should always be connected in series with the rest of the circuit. In series means continuous path. So in this case, I want to measure the current that's flowing through my light bulb. So what I do is I connect the ammeter and the current side by side like that. Okay, so that's what I mean by in series. There's one continuous path. And also in the ammeter, there's positive, negative terminal. So can you see the battery here? This is positive terminal. And then it will be connected to the positive terminal of the ammeter. And this negative goes to the negative. You can, of course, use a multimeter. Multimeter is a gadget that's very useful. It can be used to measure voltage. It can be used to measure current. It can even be used to measure resistance. A very versatile gadget. Now, So what happens when current flow in a series circuit? Again, note, series circuit means there's only one pathway for the electric charges. So in a series circuit, the current, let's say it starts flowing from here, there's only one pathway. So therefore, it is the same throughout the whole circuit. So if I know that this is, for example, 1 ampere, then at this point, it will also be 1 ampere, at this point 1 ampere, at this point 1 ampere. It does not change. So I can say that the current is the same throughout a series circuit. Okay, the current does not throughout a series circuit. It does not become smaller, bigger, because electrical charges, when it comes out, there's only one path for them to go back. So therefore, it's the same throughout. Now, if you have a parallel circuit, it will be different, because now when the current comes out, okay, I'm going to draw a simple parallel circuit. Let's say this branch is a resistor, this branch is a light bulb, okay? So when the current comes out, when you reach a junction, it will then split into two. So let's say this is current I1, this is current I2, and this is current I3. The current I1, when you reach the junction, it will split. But again, current doesn't just disappear like that. When you split, these two added together, I2 and I3 added together, will give you I1. So let's use numbers. So if let's say this is 5 ampere, when it split, it could be 2 ampere here, 3 ampere here, or it could be 2.5, 2.5, it could be 1, 4. But they all add up to give you 5. And then they will all combine and go back, and that's 5 again. So in a parallel circuit, the current that enters a junction is the same as the current that comes out from it. Okay, or you can say the current in all the branches, when you add together, is equals to the current that enters this branch. So a little revision, what we have learned. I'm going to ask a few questions. You can pause and think about the answer. So the first one is, are you able to tell me what is current? So current is the flow of electric charges, or the definition, okay, rate of flow of electric charges. And you should also know that the symbol for current is I. The SI unit is ampere. The next thing you need to know about current is, are you able to measure current? Yes, I can use an ammeter to measure. Ammeter, if I want to use to measure a current, I will connect it in series. It doesn't matter whether you put before the resistor or after, it doesn't matter. Okay, so this should be longer, sorry, this should be longer. So positive terminal, this is positive, negative to negative, right? So you use the ammeter connected in series. And finally, can you recall what happens to a current in the series circuit? Yes, the current in the series circuit is the same. So whatever this value is, it will be the same everywhere throughout. But if you have 2 branches, 3 branches, 4 branches, we know that the current will now change. Okay, so once you have more than one branch, the current, when you reach this point, so 2 ampere, maybe here will be 1, 1. In case you wonder how do they split, well, it depends on the resistors for these two. Okay, so the bigger resistor, you end up with a smaller current. But whatever it is, you add up, they should be equal to the current that enters the circuit. Okay, so read through your textbook and try to do some of the questions.